Hi, welcome to the CIDCI Online Salon Series. I'm Margie O'Driscoll, and on behalf of the CIDCI Board of Directors, I'd like to welcome you here today. CIDCI is a not-for-profit organization that relies on your financial support to provide these programs. Thank you to our sponsors who make all of this possible. As the year begins, we hope you and yours are staying happy and healthy. In 2022, CIDCI hopes to renew in-person events in a number of US cities, subject to local health directives. We miss seeing your beautiful faces and hearing you laugh. Stay tuned as we begin to imagine a new way of connecting that will, of course, include a virtual element. If you aren't yet on our mailing list, be sure to sign up at cidci.org. And here's an invitation. Please consider participating in CIDCI as a listener to these free webinars or as a sponsor. If your company needs to stay abreast of the latest innovation, and if you want to inspire your colleagues, we're your go-to destination. Okay, here's a bit of information about how today's session will work. We're recording this presentation and we'll place it on the CIDCI website and YouTube as soon as possible. If you have questions or comments during the presentation, please use the chat box. Today's session will run for 60 minutes. Today, we're going to be discussing a topic that is uppermost in our minds today. We know that climate change impacts the building and construction sector, which is responsible for a whopping 40% of global greenhouse gas emissions. A new nonprofit called Building Transparency provides open access data and tools necessary to enable broad and swift action across the building industry to address embodied carbon's role in climate change. This organization created the Embodied Carbon in Construction Calculator, also known as EC3, a free, easy-to-use tool that allows benchmarking, assessment, and reductions in embodied carbon per material category, including concrete. Today, we will hear about how EC3 was developed, how the organization called Building Transparency views its challenges, and what's in store for this ambitious group. A bit about our panel. Stacy Smedley was a sustainability director at Skanska, where she led sustainability initiatives and was the subject matter expert on LEED, Living Building Challenge, and carbon emissions associated with buildings and construction. At the organization Building Transparency, excuse me, she leads the continued management and development of the free embodied carbon in the EC3 calculator. Stacy's joined by Phil Northcutt, the founder and CEO of C Change Labs. Phil has spent his career in commercial R&D for 22 years with a current focus on climate change. He holds 22 US patents and lives in British Columbia and is best known for what we call bad dad jokes. I think Stacy's going to get us started.
Thanks, Margie. I'm going to go ahead and share my screen so we can walk through some slides and address some of the things that you mentioned through a bit of a presentation, and then we'll get into some great banter, I'm sure, between the three of us. But to start out, I think the focus of all of this is really what I would call supporting embodied carbon reduction through digital data transparency, accessibility, and alignment. And that's really what we're going to, I think, walk through today through EC3. As mentioned, it'll be Phil and I really telling the story of the why and how, and then getting into some of the what, probably with Margie. But really, I like to start with this arrow because I feel like this is our journey when it comes to the industry, really understanding embodied carbon and joining on board to try to actionably reduce it. Some of us are at the tip of the spear, others are somewhere inside this arrow, and then there's some of us that are just joining this movement. But it is a movement and it is growing. And really, I think Margie touched on this, but where this all began for the tool and for I think Phil and I both is that, you know, we are now aware, I think, as an industry, that buildings are a huge portion of carbon emissions when it comes to what we need to look at and reduce to meet our climate targets and reverse climate change. So almost 40% of it, as mentioned. The part that we're talking about today, which is the part that I think has an urgency around it because we haven't been talking about it for that long, is this building materials and construction component, where we're actually thinking about the manufacturing emissions of how we make all the things that we build with. A slide that I like to use just to kind of drive this home is this cartoon graphic. If you think about operational carbon as the energy that a building consumes during its life, really everything else to do with buildings and construction is in this embodied carbon emissions bucket. So it's all the extraction and manufacturing and transportation, installation, replacement, demolition, and reuse of all these materials that we're using to build buildings and infrastructure. So there's a lot to it. It's complex, and the goal of what we're doing at Building Transparency is really to try to help make it as simple as we can so we can take action. The other way I like to just frame this in people's minds is when you think about these emissions of building materials and that embodied carbon bucket. It's a lot to do with the manufacturing of all these things that we build with. And if you look at the manufacturing breakdown of global greenhouse gas emissions, you can start to see that the major building materials, things like concretes, steel, and even getting into things like paints and everything, you can see how much of the manufacturing emissions could be tied to those materials that we're building with. So whatever way you look at it, it is something that needs to be addressed if we're going to mitigate climate change and get to zero carbon emissions. The other thing is we know that we're building a lot. And if we're building a lot, we are emitting a lot in the making of the materials that we're putting into those buildings. If it's over 2 trillion square feet in the next 30 years, think about all of the concrete and steel and gypsum board and other things that we're actually manufacturing to fill those buildings with and build those buildings out of. And what we now know based on a lot of different entities, including Architecture 2030, is that those embodied carbon emissions, again, the things that we're making the buildings out of, once those emissions are spent at time of manufacture and installation, they are in the atmosphere. And so when you look at average global buildings, you think about operational carbon starting to take off once the building's operational over time. Even if you take that 2050 line in the sand, it's about 50-50 on average in terms of the embodied and operational emissions. And that means that 50%, we can't go retrofit the building and take those emissions back out of the atmosphere. So we have to reduce them at the time of specification and procurement and manufacture if we're going to reduce them. We have reached a kind of tipping point around all of this, and there's a couple of reasons for that tipping point in my mind. The first is really just what we now know about climate change and the way that climate impacts are being felt. Of course, this all really started with the Paris Agreement and wanting to make sure that we were staying below a certain temperature increase. Well, then last year, the IPCC came out with their new report and really showed us that it's worse than we thought. So the likely range of total global surface temperature increase between 1900 and 2019 was a best estimate of 1 degree Celsius already. So we're outperforming our temperature increase in terms of what was projected, which means that we have to reduce more quickly if we're going to mitigate that 2 degree Celsius rise. Just one more kind of science nerdy slide, because the why is so important as to why we're so focused on this, Phil and I, is that if we look at the best estimates of where we're going based on current greenhouse gas scenarios, even a very low one, by 2040 to 2060, our best estimate is 1.5 degrees under a very low carbon emissions scenario, all the way up to 2.4 if we kind of keep on going business as usual. And I think many of us will still be alive when that's happening. So this is urgent. It's not years out anymore. And the work that we need to do has to be today, not in the future. The other part of this why is that there are large corporations that build a lot of things globally that are now setting zero carbon targets and including their supply chain. So these emissions we're talking about with EC3 that we'll get into in just a second are in the scope 3 bucket that you'll see here in Microsoft's carbon mass slide. And you can see just how giant those emissions are compared to what they're looking at in terms of their own operations, in terms of energy consumption and transportation. So it's becoming something that these large corporates are aware of and are committing to zero, but on a very short time frame. So they need the tools and the data to be able to actually meet those commitments and targets. There's also stuff happening at the policy level. I won't go deep into this. You could go to the CLF, the Carbon Leadership Forum's website to really see the landscape of policy, but there's policy now being talked about around this too. So we've got private sector and public sector all talking about this. They need the tools and data to actually implement these private and public policies. So again, it's happening at various levels of policy, King County and Seattle, all the way up to the federal government and the Build Back Better Act and what was announced yesterday in an executive order around clean procurement and low embodied carbon materials. So there's a lot going on. There's also people like this guy writing books about it. So Bill Gates in his book talks about cement and steel quite passionately in terms of how we need to actually look at reducing the emissions and creating zero carbon concrete and steels in the future. So with all that, this is really where Phil and I were, I think, together about 4 years ago now. It seems like it's been a decade, but it really wasn't very long ago when we were grappling with how we could actually help with all of this and figure out a way to provide those data points and a tool that could help do something about that. Phil, do you want to jump in with anything while I'm talking?
No,
Or should
you're
I keep
nailing
going?
you're
Okay.
nailing it. Just keep
All
going.
right, keep going. So really, when we were trying to figure out where we could start with doing something about this, we started looking at the emissions of how we construct things. And these product stage emissions were really the stage where, again, it's decision making at time of specification and procurement. It's the largest piece of emissions when it comes to the manufacturing and installation of materials. So what we came up with the EC3 tool was really keenly focused on this product stage as a starting point, so we could make actionable reductions. So Phil and I got together at the Seattle office of Skanska. He was looking for a way, I think, to start his climate change software work, and had posted on a message board for the Carbon Leadership Forum. I was looking for someone to help me figure out how we could take data and make it actionable around embodied carbon and construction. We started noodling on that, and really this list of requirements for a tool started to develop. And so when we talk about EC3, it's important to remember that it's free to use. It's open access in terms of the data that we're using and the way that it works. It's transparent in terms of the way we're looking at the data and what it's telling you. I would put easy in quotes because it is a complicated topic, but we try to make it as easy to use as possible, a lot through Phil's work with our users to really understand how it needs to work and look. And then it's industry-led and supply chain focused. So keep that in your minds when you're thinking about EC3. The next part is we didn't want to be duplicative. So it's not trying to do something that another tool is doing. So there was a gap when it came to how we look at carbon emissions of materials, really at that product versus product specification and bidding stage. And that's really what EC3 is here to fill, is that gap where you're making that decision on the product you're procuring. The way we do that, just in 1 minute description, is through environmental product declarations. In my role at Skanska, I was looking for a way to get to a carbon intensity per unit of materials that's very similar to how we cost estimate, with a cost per unit of material. So you can really think of this almost as carbon estimating. And I found that in environmental product declarations, which are third-party verified documents that give us that carbon intensity per unit at the product or mix level, in this case for concrete. If you think about it, that's very similar to the nutrition label on a box of cereal, where you've got a carbohydrate per serving size. So the goal was to get all of that data in these PDF documents, where EPDs were typically PDFs that you'd go find on a website, into a digital database that we could then search and sort and use to build project level carbon estimating.
I should mention that, just as it's very much like carbon engineering is a lot like cost engineering. You need to have an idea of where your carbon is in your building, where the biggest opportunities for reduction are, so you can focus your efforts on reducing there. And most of the disciplines that people know for reducing cost, or in fact for reducing faults or reducing safety problems, for example, are applicable to carbon. We recommend basically a Pareto process. And what we're here to do is provide the tools to make that possible, so that you as builders, as building owners, and as professionals can really significantly reduce the amount of carbon that we're putting into the atmosphere within your existing flows within your existing workflows.
Thanks, Phil. And I guess this is a good slide to have up while you're talking about that, because really what we're doing is taking material quantities that you have during the design and procurement phase, either from construction estimates, as-built quantities, BIM models, and even export from the whole building life cycle assessment tool, Tally. And we can take those quantities and multiply them by these ranges of carbon intensities from the product EPDs that we have in the database. As the database grows, we have more data for that range to be kind of complete for a material category. And you can also use the find and compare materials function if you just want to go in and see what suppliers have EPDs for a particular material type in a particular location. Start to compare products that you know are equal in terms of what you could use for something like a roofing or a carpet or gypsum board, or three concrete suppliers that have mixes that are comparable. So in a cartoon graphic, this is really what EC3 is doing. You can compare materials and specify and procure low carbon options, and you can create a building level upfront carbon estimate and then a realized account of what you actually procured for your building. Just a little bit more about the backstory. Again, Phil and I kind of conceived this idea. We did conceive the idea when we were sitting there in Seattle. We wanted to get to a proof of concept. Skanska seed funded that proof of concept through an innovation grant just to get things going that I applied for. Microsoft came on board as a second seed funder. They were building a large campus and saw the ability of this tool to potentially help them, if it was successful, reduce embodied carbon emissions. And once we actually got to that proof of concept, through their support and a couple others, we were able to then turn the project over to be incubated at the Carbon Leadership Forum at the University of Washington to really enable it to be an industry-led endeavor. And that means that all of these folks on the screen gave time, gave funding, gave expertise during an incubation period where Phil and I stayed involved in how the tool would look and operate. And of course, he developed it on the software side. But we engaged all of these folks to give us feedback with the Carbon Leadership Forum support on methodology and data. And the tool was launched in November of 2019 publicly at Greenbuild. When that happened, we needed a place for the tool to go. So that's really where Building Transparency story begins. Building Transparency was stood up as a nonprofit formally in January of 2020 to take on the continued maintenance and development and ownership of the EC3 tool, all around a nonprofit mission though. So it's very important that everything that we do as a nonprofit is to provide open access data and tools that are necessary to enable this embodied carbon reduction that we are talking about. Our board is a lot of the partners that were involved in the incubation, a lot of those large technology companies that are setting these commitments and wanting to enable their teams and themselves to track these things, as well as some others that were involved in the founding of the tool. And some couple of I would call them embodied carbon nerds that have been doing this for a long time that are very passionate about this work. So that's really how we stood up. This is just a look at our current partner and sponsor list from launch to today. You can see that we've continued this model of getting funding and partnership across the building sector. So large owners, Breakthrough Energy as a philanthropic funder, and technology companies like Autodesk, structural engineers, architects, contractors, and even material manufacturers and industry organizations all wanting to support the nonprofit to make sure the tool can remain free for everyone. So it's really a paid for tool by our partners, as well as continue to meet with us on a regular basis so we can continue to iterate the tool and ensure that the tool is functioning the way it should. This is not a thing where you just launch something and it's going to be perfect. This is a very iterative process, I think, in terms of what we know and what we're learning about embodied carbon of materials. And we want to make sure the tool is staying right there in that process, really building the tracks for the train, keeping it moving. And with that, I was just going to go through a couple of screenshots of what EC3 does really quickly, Phil, so we don't go deep into a demo. But for anyone who's on the call, if you want to register for yourself for the tool for free, you can go to buildingtransparency.org and you can register yourself. If you put in your profession and organization, you'll get professional access to the tool where you can do things like share projects. You can do some of the things I'm going to show you. And if we get into questions, we can actually dig into the tool. Phil can pull it up. But just briefly, the way the tool works, again, first, if you're building a project, you're going to get estimate quantities out of a number of different places. So if you're looking at this through the project lens, you would start with a construction estimate that might look like something on the left that you're going to input into the tool in terms of description and quantities. We have a BIM 360 import that you can do. We have a Revit plugin in beta that Phil's team is working on. And we also have this export from Tally. So multiple ways to get material quantities. To get to the actual data in the tool, there's a way to search and sort by material category and subcategory. So you can go into something like concretes and then ready mix and access the database. The current database holds over 80,000 EPDs. This is actually an old screenshot. I think we're at like 65 or 70,000 concrete EPDs now, for instance.
Yep.
So again, you can go in and actually see the database in real time, how much data we have per category, and then go in and start to search and sort that data based on what material you're looking for or interested in. What that allows you to do when you get into each of the categories is start to filter down to a region or a place, filter down to manufacturers, and then do comparisons of their data. So I don't want to get in too much into all the different nuances of descriptions of all these things, but really what this is showing you for this example is ready mix concrete in Washington State, our 3 suppliers that have EPDs, and then their ranges of carbon intensities for all of their mixes. So this is where really we get excited about being able to show and celebrate the manufacturers and suppliers that are currently the lower carbon producers, celebrate that they're being transparent by creating EPDs, and then really watch reductions happen over time when we start to look at the database and how emissions start to reduce when there's competition. So in Washington, we've got clients or partners like Microsoft and other tech companies, contractors like Skanska and Turner, all using the tool to request this information from these suppliers. You can see what just happened is over time, their carbon emissions are actually reducing for their whole collection of mixes because of how they're competing now on carbon and cost. So I think this is a slide, Phil, that we made right at the beginning, my cartoon slide on the left of what we hoped was going to happen if we could do this appropriately. And that's really how do we start to look at the ranges. You know, the CLF started playing with baselines if they wanted, people wanted baselines, but really if all of those boxes start to go down, we are being successful because we are innovating and really incentivizing these suppliers and manufacturers to reduce the emissions of their materials. Similar to ASHRAE and Energy Code, that means that we can start to ratchet down the limits and the requirements, you know, closer and closer to zero as we know that the market is responding.
And one of the things that's remarkable about construction materials is that a lot of them are very carbon intensive. There's a lot of chemistry involved. There's a lot of energy involved as well. But one of the things that's really remarkable is that there are quite large savings in embodied carbon available with existing technologies. It's a metric we haven't been tracking. And you know, with any metric that you're not tracking, you're wasting a lot. That's true of almost any quantity in industry. And it's part of what motivated me to get involved specifically in construction materials, was realizing that the carbon reductions available in construction materials are some of the cheapest reductions in carbon worldwide that you'll ever find. We in this industry now have a real opportunity to make an impact at very low cost.
So the next step really is how the tool can allow you to compare at even the product or mix level. So this is just an example. If you knew that you had 3 mixes that were comparable, either from the same supplier or from 3 different ones, you can start to actually look at those next to each other and understand that, you know, if I could pick any of these 3, why would I not pick that lower carbon option as my selection? And again, this gets to Phil's point that this is the first low-hanging fruit section of these emissions reductions are these current products that are comparable that we just haven't been looking at the data point of carbon on for the industry. So there are these opportunities where we're not seeing any cost increase to get to a lower carbon option, and that incentivizes the others to reduce, and it's just this ongoing cycle. I think it's kind of like an operational energy when we figured out we could turn the light bulbs off at night and save a whole bunch of energy at nighttime or when we're not in our buildings. And that was a huge kind of aha moment, just to unplug things and turn the lights off. We have that same opportunity, I think, with embodied carbon at a pretty big percentage reduction. It's not, you know, 2 to 3%, it's 10 to 20 to 30 to 40 to 50, just by having the data available to us. The next part, just really quickly, is planning and comparing buildings. So that gets into that carbon estimating stage where you're going to go into a building and, again, have those quantities input from your estimates, be able to then search and get to those collections of data for suppliers that are within your radius of your project for the different materials. And what that really does first, before you even know what you're going to build out of, is give you a good range. So this is a Sankey diagram. I remember, Phil, when we got to this diagram before I think the tool was even functioning completely, but we thought, okay, if we could show it this way, is this something that would be useful? And I got really excited about this diagram. I think this is how I went out and I actually talked about the tool for a long time, was just using this graphic. But really on the left, what it's showing you is the relative impacts of carbon emissions for the different materials in your project. This is a very simple project that's just got you know, one material entry for each thing, but you're seeing here that ready mix in terms of emissions is a much bigger chunk than, in this case, carpet or blanket insulation. This is an underground lair for my son's dog, Chuck. So he's 10 and he built this, but you can see here that if we were going to focus on 1 or 2 materials, this is telling us that ready mix and rebar and maybe carpets, because there's a big range of reduction in that white area, which is showing you really the range of potential products and reductions. Maybe those 3 are going to be where I'm going to start. As you go to the right, it's going to roll it all the way up to a actual reduction potential for the project. And that's really going to tell you, okay, if I am smart about my procurement, I look at the lower carbon options currently available in the EC3 tool for each product category, I could achieve this percent of reduction for my project. The next step that the tool enables is really that realized accounting. So now you know the range of what's possible. If you wanted to dig into concretes, you could go in, and what you're seeing on this slide is that I've actually selected a mix. So I'm saying that I know that this is the actual mix that I procured for that concrete in that project. And it's going to show me how it's comparing to the range. So this is obviously a very good low carbon mix in that little box plot graphic that you're seeing on the right. And you can apply that to your project. If you go back to the Sankey diagram, what you're seeing now is a little R, a realized line that's appearing all the way through for each product category, all the way over to the building on the right. And that's showing you how you actually did in your procurement of getting realized emission savings based on the actual products you procured for that project. So again, a way to benchmark and set requirements and really decide where you're going to focus all the way through getting to a realized carbon accounting for your project at time of procurement and construction. With that, I'm going to kind of stop. I think we wanted to have 30 minutes or so for discussion. So really what we're seeing right now with EC3 is that we've got, I have 2 more slides, so I'm not quite stopping. We've got the ability to do these things today, and this is really what both private and public policies are asking us for. So require EPDs, search our database to find low carbon options, set targets or limits for the materials you're going to procure, and then require that this data is included during procurement so that you can get to that realized carbon content for your project. Just the exciting part bits, I guess I will stop. I was going to share about the kind of current use of the tool, but I think I hid those slides. We're currently at around 20,000 registered users of EC3 in over 70 countries. We started in North America with about 1,000 people on the wait list, and now you've expanded to this growing. It's the curve I don't want to flatten. It keeps on going up in terms of folks that are engaging with the tool. I think that's just another reflection of the tipping point that we're at, where this is becoming something that people are really wanting to engage with and understand.
Great. Phil, did you have anything you wanted to add now, or should I start pummeling you with questions?
I'll just do my brief spiel. You know, one of the key things about, you know, our industry is that, you know, it's a big, complicated industry, but ultimately, the thing that's going to make the biggest difference is if people who are buying buildings hold, you know, our profession and the entire supply chain to account for embodied carbon. We all know that if something has a business case, if the client asks for it, it gets done and it gets attention. And there is an absolutely irreplaceable role that building owners can have in asking their professionals and supply chain to declare the embodied carbon, the carbon they are spending in order to build the building, and make sure that we're doing that in an efficient way and we're not wasting. And if you take a look at the way we launched, one of the very important factors was that Microsoft was building a $3 billion campus in Redmond. And as a result, no supplier in the area of Central Washington could afford to ignore what this project was requiring. And so they brought the professionals and the suppliers to the table, who then had all the data and expertise needed to, at very low cost, significantly reduce the carbon. And once they got used to it, they have now, you know, in many cases, those companies are doing exactly that worldwide. And, you know, we now see companies like Amazon having a very similar impact where they are operating, also using the EC3 tool. So I would say any of you who are involved in actually procuring buildings, in owning buildings ultimately, have a completely irreplaceable role, because as they say, he who has the gold makes the rules. And even in the absence of a world government, a buyer's authority extends across corporate boundaries and across country boundaries. We are entirely capable of solving this looming catastrophe that's looming over our kids. We just need to organize, and we at Building Transparency and of course See Change and Support are here to help and to spray WD-40 on all the bits of this process that are stuck to try and make it as easy as possible to do the right thing.
Do you think that government regulations can also play a role in forcing businesses as they're going as part of their permitting process or in some other way to require this sort of reporting and analysis?
Yeah, I mean, we're seeing that already. I think, I mean, I try to frame this. So there's private policy and public policy. So the private owners that Phil mentioned, as well as many others, are doing that of themselves. So they're setting the requirements on themselves if they have the kind of the commitment to do so based on their climate goals. But public policy is doing similar things. I think in this one case, it's a little behind what some of the private policymakers are doing right now.
They're ahead.
Yeah. So what's important is that, and what's happening right now with examples like Biden's executive order and then what came out from the White House yesterday, where they're putting together task force that they want to be cross-sector to look specifically at low carbon material procurement of construction. We're starting to see this kind of learning happening. Our big focus is supporting policy no matter where it's coming from, but working as that conduit to help harmonize and align what the requirements are, so that ask to that concrete supplier, whether it's from the federal government, the state government, or a private owner, is the same ask, and they can comply with all three at the same time. And Phil can talk a lot more about, I think where he started with some of this, which is how we look at the carbon intensities of materials through the lens of global trading and things like that.
Yeah. So what I would say, just really broadly, at a practical level, there's three things that governments can do. One of the most obvious is that governments are large procurers of construction materials. They build a lot of stuff, especially in transport, but in lots of areas. So they are a very, very powerful buyer, and even before passing any, permitting or anything like that, their actions as a procurer can have a huge impact. And we've kind of developed a method of doing that is completely compatible with public bid and tender. The second thing they can do, of course, is encourage and support domestic production to be as clean as possible. But eventually, we're going to have to deal with the fact that these goods, cement, steel, aluminum, and quite a number of others, are traded across borders. But when we emit CO2, it has the same effect on our kids, whether the CO2 is emitted in Chicago or Chennai or Chongqing. It's much of a muchness. It's a globally well-mixed gas. What that means is that when we are importing materials that are high carbon by their very nature, we are going to need to hold the producers of those materials accountable. And ultimately, that's going to mean applying the same kind of policy, such as a carbon price, at the border as well as internally. Ultimately, that is the only way we are going to decarbonize our economy without simply exporting our jobs, which would be completely pointless because it wouldn't get us anything and we'd lose our jobs. And that ultimately, where we're going to need to go as a society probably is something called a border adjusted carbon tax. And they're starting to see this in Europe right now. But if anybody wants to know where the end goal probably has to be, that's probably where we end up in order to have a stable economy in which it doesn't, you don't get rich by cooking the planet.
Great, thank you. One of the questions that are one of the things that often happens in the building industry is people in, say, a construction firm get a lot of calls from technologists who say, I've got a solution for fill in the blank problem. And a lot of times that's not actually a problem within the building industry. And so I'm wondering if you can unpack a bit for us how your first conversation went. Stacey, you said you saw something on a message board. Phil, you cared enough to post that. how did that actually go? Because I often feel like there's a lot of skepticism between the world of technology, which is obviously so necessary to solve these big problems, and the design and construction industry. So could you talk a little bit about that? Because I have a feeling there's a story back there.
I mean, I can start. I think, you know, the initial little nugget of an idea behind EC3 came from a need that I had very explicitly at Skanska. So it wasn't trying to come up with some magical solution I could go sell to people to, you know, make profit. It was, I'm Stacy, sitting at Skanska at a construction company that has 0 carbon targets, including their supply chain, by 2045. And we're building for clients that are having also making similar commitments. How in the world do I get to the data I need to actually support those targets and commitments? And I was working in pre-construction, also doing sustainability director work. And so it was just this, there was a problem statement that I was trying to solve. And I had a company that also had innovation grant funds I could apply for if I had something I could propose as a solution for a problem that Skanska and also the larger industry needed to address. So it was just kind of the perfect place for me to be sitting, but also this problem that I was discovering that is not a Stacy specific problem. It was a problem that was a sector problem in terms of how to look at this. And I was a member of a group of embodied carbon nerds on the Carbon Leadership Forum's initial, you know, message board. And Phil piped up and said he was trying to find a way to really get into, you know, solving climate change. And was there anyone that needed software or developer services? And I was like, well, I think what I need is a software tool. And so I feel like I could probably go find the initial emails. I haven't read them in a long time, but you could probably tell your side of the story. But it was me saying, I think this is a person that actually is a software developer who cares, which I think is another part that is very special, is that it's not like Phil just goes and builds stuff that we ask him to build. He actually learns about all these materials and their emissions and wants to understand the use case of each of these pilot partners that we have. So he's a developer that cares. And I think I saw that in his posts. And then I don't know, Phil, I think you reached out to me though. Is that true?
That's true, I did. That's true, I did. Yeah, I mean, I describe Sea Change as a mission with a company. You know, fundamentally, we exist to address climate change, and the weapons we have to bring to the struggle, you know, are software, databases, user design, and you know, I've been I could see many of the, you know, the opportunities where technology could really move this ahead, because truthfully, my industry, you know, IT has not served construction well, to be honest with you. But when Stacy came forward and said, you know, we've got a major we've got a major builder who wants to do something that has a problem. We have a major project that could be an anchor, like you know, that could be a localized tipping point just within one jurisdiction. I could see right away that if we poured in everything, you know, we had an opportunity to make a real difference. And you know, we were very fortunate with our timing. And you know, every great software success is a labor of love, and C3 is no different. You know, we as a group are very dedicated ultimately to this fight against climate change, and we will do what it takes to help the community, to arm the community with the data that they need to let our competitive free market economy drive us towards a place where our kids have a decent life and our civilization survives.
I think the one other thing I mentioned just that I think is unique about, you know, how this all began was that the companies involved at the beginning, you know, the Skanskas, the Microsofts with seed funding and their campus project, you know, Carbon Leadership Forum, and Magnus and Klemensic Associates, PanCat Foundation, all the kind of an interface, all the initial funders and folks that we reached out to about this when we were thinking through it, all of them wanted it to be a free open access tool. There was no ownership that anyone was requesting or requiring. In fact, it was much more of like, no, this can't really be owned by a company if it's going to make the impact it should. So it was a very impact driven group of people and companies. And I think that's also unique. we get questions all the time from VC funders that don't understand our business model. It's like, you have a software, but it's free and you're at a nonprofit. How are you making this work? So there's a unique case about just the premise of the tool being this thing for industry, and those initial companies, and then those industry partners at CLF, all those 50 companies really got behind and could see the value and potential in. So that has to be stated, I think, as part of this.
Yeah.
Yeah.
And just to be clear, this is a tool that will be free for as long as it can be supported free. And for now, that's we see no reason why that will ever end. The point here is to spray WD-40 on all the parts of the climate problem that are stuck.
So I'm hearing you both talk about the attributes of the EC3 tool, and I'm wondering what advice you might have for technologists as well as construction companies about how you made this partnership work better than so many often do.
I'm going to start by saying it comes from a lot of mutual learning. I had to learn an enormous amount about how construction worked. I needed to listen very closely to what Stacy said about what the actual problems and language of the building community was, to people like Don Davies teaching me about enough about structural engineering to be dangerous, at least. Working with one industry body after another who have worked very closely with us to build up these categories, because every one of these material categories is special. They're all a little different. They all have special considerations. We need to learn, understand that, and then express it as best we can in our software, put it in front of the users, and let them tell us, that we did it wrong. And then we go back and we do it again until we get something that's really pretty good. So I would say a lot of mutual learning.
I mean, I don't know how typical that is. I mean, obviously this is my first, and probably, who knows if it's my only, but it's definitely my first foray into software development. And I don't know how unique it is, but the fact that we have ongoing biweekly engagement with people where we sit down and Phil walks them through the tool and can take criticism. I mean, it's very, we will show them something and we will say, please don't hold back. Like,
Yeah.
this is not working well, tell us so we can go try again. And so that iterative process of being open to criticism to make sure that our users are the ones that are informing how it actually functions is fairly important, I think, to actually being successful. So it's something that, I think we both enjoy it too, Phil. It's being able to talk and come up with these relationships with all these different entities and organizations across, all these various different parts of the problem.
I think that open-mindedness and curiosity, as well as constant user testing, is what's made the tool as useful as it is for people, and being open to a critique. As you said, this is working. I don't understand this. However that might be with your actual users. So congratulations to both of you on that. We have a question from Aaron Anderson. Aaron, I was going to unmute you and let you ask your question.
Yeah, this is Aaron Anderson with Swinnerton. In the Q&A, my question was really about just electrification. And first, I want to say thanks for putting these tools out there, because what it's done is it's allowed us to actually experiment and figure out what's happening with product, but also with our own processes and what we're contributing. But a lot of the access to a lot of the EPDs, I realized that tons of this stuff, tons of the carbon in all of the materials is coming from the grid mixes. And in a lot of places we're being, basically, like, we talked to some Canadians last week, and they were looking at potentially purchasing steel from another province because of its energy mix. So I'm curious about that from a public policy point of view. It seems less of a free market issue and more of something that's being constrained by public policy, essentially, but maybe also, in our country, also the actual utility behavior. So maybe you guys could address that.
So you're right and you're wrong. So the the part where you're right is utility behavior does matter a great deal. Grid mixes matter a great deal. In some materials like aluminum, the grid mix is completely dominant as a function. I will say that it's the electrification is not nearly enough. The both concrete and steel have very large emissions just from the chemistry. So, for example, when you're making clinker, one of the core things you're doing is you're taking calcium carbonate, CaCO3, and you're cracking it into CaO and CO3, because CaCO3 is just a CaO and a CO2 put together. You crack them apart, you get the CaO, which is your quicklime. That's one of the core ingredients that is going to drive the whole cementitious equation. There's a similar reaction when we contact carbon monoxide with iron oxide in a blast furnace to make iron from iron ore. Another thing is that a lot of these processes involve high heat, which again is usually done by burning a fuel, so that you use the higher heating value rather than the lower heating value you would get if you were heating it electrically. That said, there's a whole bunch of other things where it's absolutely true that electricity matters a great deal. And if you want to look at the single best way of sequestering carbon long-term in the ground, it's a technology called NBC, which stands for not burning coal.
So the one thing I'd add is just that what we've seen, part of this starts to look at where it does start to look at the grid, and there's cases where there's in the US national steel producers that have some plants that are lower carbon based on where they're located and the grid mix they currently have, and those are starting to see more requests for their materials to come from those plants. And then at their other plants, they're looking at things like on-site solar, or how they can do renewable energy purchases from their utility providers. So some of this is helping to push the market to see that there's maybe a sector requirement or request for decarbonizing grids and finding cleaner energy sources. So it all kind of relates. We do need, in the stuff that's happening at the federal level in the US, there is a lot of money going into investing in clean energy that will then help us when it comes to the thing that you're talking about, which is the grid profile of the plants. But again, it's just now that even these suppliers understand that their grid mix is part of their problem, they're looking for ways to solve that so that they have a lower energy consumption profile and within their EPD and their product. So, just providing that data is helping.
Great. We have a question from Guru. I've unmuted you. Would you like to ask your question?
His audio has not come through, so I'll read the question. So how do we plan to address data gaps in the global south? How do we incentivize product manufacturers to get an EPD, especially the local and small players, because getting an EPD made is really expensive right now. So this is a real problem. We are doing a bunch of initiatives to try and make getting an EPD cheaper and faster, and maintaining it be cheaper and faster to support everybody, not just the small local players, but also, there's many companies make 500 or 1,000 products, right? And ultimately, we need really greased ways of doing this. And the basic inspiration is we take a look at what's sometimes called Industry 3.0, which is to say how modern inventory systems track quality and backlogs, the wrong term, inventory. And there's been enormous reductions in cost of managing that stuff through the smart use of IT tools. So we're working quite hard on that. In particular, one of the initiatives is called OpenEBD, which is an open global standard for program operators, tools, and databases to exchange electronically complete EPDs in ways that can be put into databases and connected to ERP systems and all of the things that all of the tools that we routinely use to manage our businesses. And by doing that, we are hoping that we can reduce the cost of EPDs by, well, in some cases, an order of magnitude, more commonly a factor of 3 or 4, because ultimately we're going to need to do 10 or 100 times as much sustainability work, and we're not going to have 10 or 100 times as much money to do it with.
I'll talk a little bit maybe from the non-IT perspective too, because there are things that are happening right now around this just based on kind of current state. So the first thing is, if you're in a place of requesting EPDs, do so. So whether that's an owner request or an architect request or a contractor request, just requesting the EPDs of the supplier can give that sustainability professional at that manufacturing facility what they need to go say, there's a business case for this, we should make this investment. And the other thing about EPDs is once you've made that investment once, it becomes freely available to everyone. So you're fulfilling the request for all by fulfilling it for one. But they might need that business case. The second thing is that we're seeing competition now where there are multiple players that can provide EPDs start to drive the cost to go down. And that will just continue to happen, I think, as more folks kind of get into the space and say, hey, we can offer you a solution in EPD for less than this guy can. So that's starting to happen, I think. And that's another part of this, which is positive. The third is, if there are ways to do things like grant programs for small suppliers, that's something that's proposed in the federal Build Back Better Act here in the US, where suppliers could actually apply for a grant to pay for their EPD production so that they could then can support and compete the compliance coming from different policies and private companies. So that all of that needs to happen, I think, and all of it's starting to happen. But really, it's that request for the information first and then support and getting it at a reasonable cost. And we're trying to help support both.
At the end, I'll toss it back to Guru and ask, if you could think of ways that, we could serve the global South better, I would love to hear it. I know I'm very ignorant about the subject. I'm ignorant about lots of subjects. So if you've got ideas, we'd love to hear them.
Hey, yeah, I was just wondering, so you mentioned about the open format, right, where people can upload data and make it available for everyone. How strict is the screening, like if I have data, even how do I need to get certified, or what kind of labels do you look for when I want to upload those kinds of information onto EC3?
You need a program operator to sign off on it and a third-party verifier to have verified it. We're working entirely with type 3, which is to say externally verified EPDs.
Okay.
We can, Guru, if you want to reach out to us, these are the things that we're more than happy to jump on a phone call and talk through. So open invitation for us to actually find time.
Recently, there's been a carbon leadership branch which is opened in Bangalore, Carbon Leadership Forum, and I think I've been following their programs and initiatives. So I think I'm kind of getting involved a little bit there. Yeah, I'm also wondering if there is some kind of an incentive structure we could explore through Web3 tools, I mean, it's just a high level idea that I've had in my mind, just thinking about it. Yeah, what do you guys?
Great. Thanks. And that might be a really good thing to follow up with in the future.
Thank you. Yeah.
Great. Thank you, Guru. So we're coming sort of to the end of our time together. I'd like to give you both a chance to reflect on what's next for the movement and building transparency.
I'll start with what's next for building transparency. I think, again, this is a huge, there's more to do than we currently can do all at once. So part of this is just being really smart about what we do when. But things that we're working on right now are, again, more material categories published to the public version so that people can access the data. So working really hard with industry organizations to push out the data that's well curated and filtered. So there'll be more categories coming this year. Global scaling, we've got our first partner in Asia through Obayashi, a large general contractor based in the Asian market. We're looking at how to help support EPD programs in markets like China, really, again, making this the global initiative it needs to be. So global scaling and just, more data availability are really important to us. Then I think it's the third thing is just how we help to make the data accessible in all the different places across the process, whether it's design tools and construction procurement tools. So working with folks that create those different tools to make sure that EC3's data can be used.
Yeah, and I was just going to echo that third point is, there's a lot of tools out there that do a particular job really well. I think it's our job to make those tools work together so that individual users, don't need to wrestle them all to the ground. They should talk to each other pretty well, because this is a big subject. There's a lot of people working on it. We need to work together towards the end goal of making a big difference, doing our part to mitigate climate change.
Well, thank you both. You're both an inspiration to us, and it's so exciting to hear people who are so deeply from the heart interested in solving this problem, and then embracing the really technological or nerdy side of your personalities. And that's your self-defined term. But really, I mean, it's this combination that's just so inspiring of using wisdom, smart, and also the heart to help solve these problems. Because ultimately, it has to be all those things if we're going to come up with winning solutions to this, really horrifying situation we've created for our planet. Because I don't want to leave on that sad note, I'm going to ask Phil for a bad dad joke.
All right. Well,
and then I'll do
Katie,
an outro and let the audience know what's next for CIDCI.
I'm gonna make Katie answer this one. So why does a chicken coop always have 2 doors?
I don't know.
If it had 4 doors, it'd be a chicken sedan.
Phil, it's been so much fun to hang out with you. Stacy, you're so amazing and so inspiring to all of us. I'd like to thank everyone for being part of this conversation. CIDCI will be back on February 25th with an entirely different kind of conversation. Longtime business consultant Gloria Flores is going to discuss with us learning to learn and collaborate with others, navigating moods in the workplace and beyond. Although most people can tell when they're in a good mood or a bad mood, moods are much more nuanced and influential than most people realize. Prepare to learn something about yourself that you may not yet be aware of. Special thanks today to Katie Olson for keeping us on track, our sponsors who made all this possible. And thank you so much, Stacy and Phil, for the work that you're doing. We look forward to having you back again to let us know what you've accomplished in the next year. It's been really fantastic.
Yeah.
Thanks so much, Margie. Bye-bye.
Thank you so much.